Hi everybody, welcome to our online event. I think today is the first time we're doing it in English. We call this type of events like seminars. We're trying to keep things really friendly and informal here. It's not an official meetup conference or anything like that. So our goal is to create a space where people can share their experience in different areas of machine learning, data science, AI, advanced data analytics, and so on. The name of the community, NoML, stands for not only machine learning, and it suggests that the idea that we want to cover a broader set of topics in the area of advanced analytics or even applied mathematics. So MLOps and ML platforms is one of our favorite topics here. It's because of these technologies we can have our ML AI applications up and running in productions and bringing real value to business. So I'm really glad to have our guest speakers today from the company ClearML, Tina and Nathan. Welcome and thank you again. So for our online listeners, you can ask any question during the talk. You can do it in the chat in Russian or in English, or you can ask questions directly in English, but please, to keep things nice, raise your hand first. You can see such a button below. I will try to find a moment to interrupt our speakers and give you the mic for the question. After the talk, we usually have a Q&A and discussion session. Sometimes our discussions can really drift away. So Tina and Nathan, don't be afraid if we'll start discuss more general stuff about MLOps, ModelOps, model lifecycle management, and so on. Once again, guys, welcome. Thank you. The floor is yours.
Wonderful. Hi, my name is Tina Naro. I'm the Senior Director of Product Marketing from ClearML, and I have with me Nathan. I'll let you introduce yourself, Nathan.
Thank you, Tina. So hello, everyone. Thank you for joining. I'm Nathan. I'm a pre-sale and support engineer in ClearML. I've been a bit over 5 years in ClearML, and I'll be going over the demo and presentation together with you today. And I'll be very, very happy if you have as many questions as possible. Please don't be shy.
Wonderful. Nathan is a fantastic resource, and we are very lucky to have him. So as he said, I will give a very brief introduction to ClearML, and then I will pass it to Nathan for demonstrating our platform. But first of all, I want to thank Olga and Pavel for having us here today. We are happy to be speaking with you. So ClearML is a company that is we are essentially an AI/ML platform designed to help you run your model production from lab to production. The reason that ClearML came into being, so let's start from the very beginning. Companies normally adopt AI for two reasons, and you know these reasons very well. One is for product innovation and expansion, and the second is to obviously generate more sales. But as you have obviously experienced, it's very hard because AI is not your traditional IT project. It requires a lot of coordination. It requires many stakeholders, including engineering, product, and R&D. And the development process for AI/ML is usually not straightforward. So there's a number of products on the market, some of them very good, but they do very specific things. And when we've been speaking to customers and prospects in the past, we understand that their process in getting things done from start to finish can be quite complex, jumping from system to system, solution to solution, and having to make them all work together. So it adds a lot of time, it adds a lot of processes, really slows you down in terms of productivity. And every step of the way, maybe something breaks and you're running against, basically you're finding problems and you're needing to troubleshoot them. ClearML helps simplify the process by offering a faster delivery with everything on a single platform. So as I alluded to before, ClearML, maybe you're jumping from solution to solution. However, with ClearML, we provide you with a single platform so that you can work on one platform to get things done. And we offer this through an open source modular architecture. So we are end-to-end. We are also open source. You are allowed to, or you can plug in your favorite tools, your favorite data management tool, experiment management tool, infrastructure monitoring. All of it can be added into our system so that you have the customized AI ML platform that you want. It starts very easily with 2 lines of code through Python, which Nathan will show you. And we have found, and our customers have found, that through the usage of ClearML, you're able to work in a more streamlined process. Everyone is on the same platform. There's better communication. There's better management of resources, who can access what, whether it's a database or a GPU. All of that is built into the system so that everything works very fluidly. There's no need to take time out to fix this or fix that or give somebody credentials. It's all built into the platform, which makes things run much faster. An overview of all of our components. So with ClearML, as I alluded to, you can really run everything from start to finish, beginning from data operations with your data ingestion and your pre-processing. We have robust capabilities for cataloging your data and versioning your data so that all of it is available to everyone who has permissions to view it. Then you can move into experimentation and training, where you run your experiments and everything is cataloged and stored. All of your settings are saved so that it's completely reproducible. Nathan will go into great detail about how it's very easy to share your work. And for the training part, as I alluded to, it will tie into the orchestration and scheduling, but essentially ClearML makes it incredibly easy to orchestrate all of the needs of compute for the team. So whether it's running data pre-processing, whether it's running your experiments, whether it's launching and deploying your model, all of it is connected to an orchestration layer, which enables everything. It's kind of the glue that facilitates the whole process. And Nathan will also go into deeper demonstration of the system. From a productivity point of view, you have reporting. So we offer robust markdown reports. You can embed live charts, plots, scalars, and you can even embed these into your favorite third party. So if you use Notion or Confluence or Monday.com, you can embed our charts and graphs into those so that you can build live real-time reports for your colleagues. Pipelines are one way of automating. Model store, as I kind of mentioned before, is the storage of all your models. Trace your model lineage, compare your models so you can see exactly what changed from model A 0.1 to 0.2. Pipelines, we have robust pipeline capabilities for you to really build automation into the system so that you no longer have to do everything so manually. And then lastly, we support serving and monitoring. So you can deploy your model using ClearML and you can monitor it with the live endpoint monitoring dashboard. And again, that's all underpinned by a very robust orchestration layer that enables scheduling. So one of the main benefits for ClearML scheduling is that you don't need Kubernetes, and Nathan will go into that in greater technical detail. And just overall, it's very easy to manage your compute with ClearML. And with that, Nathan, have I forgotten anything, or is anything you need me to cover before you launch your demo?
No, Tina, I think you covered it pretty much very well. Thank you for the introduction and the intro.
Wonderful. So I will stop sharing my screen now, and I will turn it over to you.
Okay, so I'm sorry, give me just one moment to share my screen.
Yeah, maybe someone have any questions?
Yeah, actually, if anyone has any questions before I begin the demo, it would be very good. I guess we
think
take it as a silent no.
Yeah.
Okay, so hello again, everybody. Thank you for joining and listening in. So I will be going through the ClearML system, and let's jump right into it. So the first module I want to cover is experiment management. And from the experiment management itself, we build a lot of visibility into the different processes that we have. And from that, we can build a lot on top of it. So the way that we manage experiments is through objects that we call projects. And you can think of projects as very similar to directories, meaning that you can create subdirectories as wide or as deep as you would like. So let's go into the examples project. Now, when I go into it, the first thing I see is all of the different sub-projects inside this example project, but we can just go into all of them. So the first thing that we encounter is the overview of the project itself. And the overview basically provides us with a snapshot of some relevant metric that we want to present. And of course, we have control over which metric we are showing. And beneath that, we have a markdown editor, very similar to what Tina mentioned regarding reports. Basically, we can embed outputs from the system, from experiments, and visualize them inside this overview. And if anything is actually running, it will be updated live. So here we have some plots, and underneath it we have text. And of course, because this is a markdown editor, we can mix and match in any way that we want. Okay, so now if we go into the experiments themselves, we will encounter the experiment dashboard. And the dashboard by itself is pretty smart, meaning that we can customize it in any way that we want. We can move around columns. We can add custom columns according to our own metrics and hyperparameters if we want. But let's first jump into the experiments themselves and understand what this object is actually about. So every line that you see here is actually in one of three states. It is either a code, Python code execution that has happened, is happening, or will happen. So has happened, this is very easy to understand. We can go into the details of an experiment, check the console logs, and see everything related to it. But let's say now we have some code that we want to run, and we want to integrate with ClearML. So I'll go into the code. What we have here is, and I will run the code as I'm speaking, just to save a bit more time. And what we have here is a very straightforward example of using PyTorch to train on top of MNIST to create a model that is able to recognize numbers. So the most basic hello world example possible. So to integrate with ClearML, we need quite literally two lines of code. So the first one, we import the task object from the ClearML package. And the second step is that we initialize this task object, and by providing it a project name, basically where we want the experiment to sit in what project, and then we give it a name. Now, when I talk in relation to ClearML, whenever I say experiment or task, this is basically synonymous. This means the same thing from our perspective as a company. The task or experiment is just any Pythonic code execution. Okay, so now, as I said, I started running the code as I was speaking. So the first thing that happens after I initialize this task object is I will get a link to the web UI to see the task object itself, and then the code will start running as is. So in this case, it's just starting training. So if I click on this link, this will take me to the experiment or task object. Now, let's cover first what we get from this task and what we get for free just by adding these two lines of code into our existing code base. So first of all, as I mentioned, we have the full console output. So this means we no longer have to dredge through PyCharm logs or any local log files. Everything is already in ClearML. Next up, we have the execution. So the source code parameters that we use to run the code. So we log automatically the repository that was used, which commit ID was used, and obviously which script. Then we also log all of the uncommitted changes, because most times no one commits their changes before running their code. And we will also automatically log any installed packages. And this is in order to be able to recreate the environment that we want to run this experiment in the future. Configurations. So ClearML will automatically connect to your arg parser. So in my code example, I have an argument parser with some arguments. We also integrate out of the box with Hydra and OmegaConf. And if you have your own custom configuration files, you can very easily connect them into the ClearML system with a single line of code. So for example, task.connect configuration, and then we simply give it some path to a file. Or we can connect Pythonic objects directly with task.connect and provide it with some Pythonic objects, for example, a dictionary. So all of this will show automatically in the configuration section. In my case, my example is very simplistic, so I just have the arg parser, and in the arg parser, I have some parameters. Artifact section, this is where the output model will be logged once the experiment finishes running, or if I had some checkpoints, then it would add the checkpoints as well. And also, artifacts are a way to expose any type of output that you want that will be accessible by other tasks in the system. And we will touch on this when we get into pipelines. Data views we will skip for now. Info section, here you have some dry information about the system that is running the experiment. So you can see that I'm using a 2080. I'm on a Windows machine. Please don't judge me. But nothing very special, just a bit of dry information about the system that we're running on. Again, the console outputs, very nice to have it available in the web UI. Now, let's talk about the outputs, scalars, plots, debug samples. So ClearML will basically out of the box automatically detect whatever frameworks you're using. So if you're using TensorBoard, XGBoost, just for example, to name a few, ClearML will automatically detect whatever you are reporting into those frameworks. So for example, if you're reporting something into TensorBoard, everything reported into TensorBoard will be logged automatically into ClearML without you having to add any extra code. On top of that, we also monitor the machine usage. So we have the GPU and CPU usage of the machine itself, also the memory, network, and a few other parameters, basically to give you an indication of how used or how utilized or underutilized your machines are. And of course, on top of that, we can add any type of visualization that we like, including debug samples, basically images, sound files, HTML files, anything that you can think of can be shown here as well to visualize everything. And as I'm speaking, I see that the experiment moved to a completed state. So now I can go into the artifact section, and I can see the model that was registered. Just to give you an idea of how it works, basically, in the end, whenever you do torch.save or you save any other model in any other framework, we will latch onto it automatically and log this model into our model repository. So I can see the model here. If I click on it, it will take me directly to the model repository. I can see where the model was stored. So through ClearML SDK, I also have control where I want to save my models. And I have full ability to trace its lineage, like which experiment created it and what other experiments are using it as an input model to retrain, for example. And of course, you can add scalars and plots on top of models just to give more visualization and indication of what is happening. So this is the experiment management module. Now I'm going to go into orchestration, but just before I go into orchestration, are there any questions from the crowd? Yes, Igor, hi.
Hi, Nathan. I have a small question. For instance, let's say a data scientist inside the Jupyter Notebook has installed some library and then train a model. So we have dependencies inside the ClearML, and we have an artifact ML model. Then the data scientist reinstall or change the version of a library that he used for training and do nothing. So how it affect the environment inside ClearML? Does we rewrite the dependencies but do not change the model? Or
Okay, it's a good question. So what will happen is basically we log everything during the code execution itself. So the exact environment that you have will be logged as is. So if, for example, later you're still inside the same Pythonic environment and you do pip install to another package or version of a package, or do pip uninstall, this will not affect ClearML in any way. Only when you run the code again with the relevant imports from ClearML, and as I mentioned, the task.init basically, then the ClearML will log the new code execution with all of the parameters and packages that were present during the execution of the code itself. So we're not actively monitoring your virtual Pythonic environment. We are only monitoring the code execution itself.
okay, thank you.
Thank you. Any more questions? Yes, Igor, please.
I have another one question, but I think it is general, not linked to experiment tracking. Do you have differentiation of rights inside the ClearML? For instance, for me as MLOps engineer, can I have an admin panel inside ClearML and different rights for data scientists which will use it?
Yes, very good question. It is fully supported, so you have role-based access controls on top of ClearML, where you can actually segregate between the projects, where users can either see or read, write, or have no access at all whatsoever. You can apply this to the projects, you can apply this to the data management features, and you can also apply this to the orchestration features as well, meaning that you can decide what user has access to what machines. So for example, if you have like very expensive GPUs, you can say, okay, only this group of senior users, they have access to those very expensive machines. So role-based access controls is enabled all over the system, and it's available. I'm sorry, I don't read Russian so well. So
Yeah, okay, I will. The question is, can you compare the experiments from different projects?
yes, and I will cover this in like 2-3 more minutes, maybe 5, but this is part of the demo as well.
Okay.
Okay, so if we don't have any more questions, I will. Oh, we do. Mariana, yes, please.
One moment, I'm typing.
And I couldn't hear you.
Okay, I think she said that she's typing her question. So, what is the way that the champion model can be selected, determined, or something like that?
So this would basically be covered in your code. So you would have some sort of parameter to decide what is the best model, because how can you decide what is the best model unless you give some set of parameters and say, okay, according to these parameters, this is the best model, and you can simply implement it into the code. And after that, you can also tag and add the extra information on top of any model. So every model, you can add metadata labels to it, and also tags. So for example, you can say, okay, this is a very good model, so let's call it the best model or production. And then, of course, you have full control over the tags themselves in the system. So you can say, okay, this is good enough, not good enough, and create basically your own heuristics according to what you want to decide if the model is good or not.
Can you please click back to experiments?
Can you place what?
Click back to experiments. You're now on models, but I want to see experiments.
Yeah, in the lineage, I can just click on it, and it will connect me directly to the experiment that created this.
And in artifacts, there are one more champion model or each run that I started.
So it depends on your code. For example, for saving checkpoints from .save, These checkpoints will be saved automatically and logged into the system. Of course, the final model will be logged as well. And even on top of that, you have full control. Do you want to log automatically, or do you want to log only manually the whatever specific checkpoint you have according to some parameters that you decided are good enough?
Thank you.
Sure. Thank you for the question. Okay, I think at least for now we don't have any new questions. So I'll continue to the next step. So the beginning was just me running my code, my machine learning code on my local machine, just to see that it doesn't break up apart. But what if I want to run my experiment on a different machine with a much better GPU? Because I have a 2080, it's very nice for running computer games, but it's not very good for actually doing deep learning or machine learning in general. So now I can take the experiment that I ran, I can right-click it, and then I can clone it. And by cloning, this means that I'm now creating a template of this experiment. So I have the source code, I have the uncommitted changes, installed packages, all of the configurations, but none of the outputs are existent. So for example, you see there's nothing in the info section, nothing in the console logs, scalars, plots, artifacts, everything is empty. But now, when this experiment is in draft mode, this template, we can actually edit everything. So we can edit the source code. So instead of running on a specific commit ID, I can say just run the latest branch in master. Okay? And think of this in relation to automation. This means that you have also full control over the source code that is going to be run. So you can actually create entire CI/CD processes just from this idea. Of course, the uncommitted changes can be changed, the installed packages, but the really interesting part is also the configuration. So now I have also control over the configuration. So I can say, okay, instead of 10 epochs, let's run for, I don't know, not even 12, 13 epochs. Let's change the learning rate to something very silly, and maybe change the random seed to lit. And after we change the different configurations, and we're happy with them, and we want to run our experiment, it is very straightforward. I right-click my experiment, I click on a queue, and I select the queue that I want to push this job into. Now, I want to expand a bit what this means by pushing a job into the queue. So this touches on our orchestration level. And by the way, you can see that my new experiment already started running. So this takes us to the orchestration layer of ClearML. And the way that we do orchestration is by abstracting the hardware resources themselves into a queue. So queues, you can think of them as basically, on one hand, a list of jobs that are supposed to be executed. So here I'm looking at a queue. I can move jobs around. If I want, I can remove them from the queue, or maybe even add new jobs. So this is one part of the queue. The other part of the queue is that the queue name itself is an abstraction of what resource we will be getting. So for example, calling a queue alone is not a very good naming convention, simply because I guess only alone will know what resource is listening to the queue. But if we call a queue 1x GPU or 2x GPU with more specifications, or if we want, we can even say, okay, 1x GPU Tesla T4 and rename it to that. The user, the end user, will actually know better what resource he will be getting when he's pushing the job into execution. So this is just the queues themselves. The other part of our orchestration is what we call ClearML agents, or workers, basically. And the agents or the workers, what they do is that they listen to a queue. Every 5 seconds, they ping the queue and check if there's anything new in the queue. If there is anything new in the queue, they will pull this job from the queue, so they will remove the job from the queue itself and start executing the job. Now, what does it mean by executing the job? So basically, what it will, the agent or the worker, what it will do is it will take the experiment or task object from ClearML, it will recreate the exact Pythonic environment required to run this code, and then it will run it, but with a small change that it will actually go and check the different configurations that we put in the configuration section and inject them into the code during runtime. So here, basically, what we see is happening is that at the start, the agent is basically writing out, okay, task ID, blah, 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 pulled from QID, blah, 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 by some worker. And then it is saying, okay, I'm running task ID, blah, 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 inside some default Docker image that I personally pre-configured. And now what it will do, it will run all of the installations required, all in order to clone the code repository, apply any uncommitted changes. Let's see, there we go. Apply any uncommitted changes, and then it will start installing all of the different Pythonic packages that were logged into the installed packages section. Not just those packages, but obviously also the dependencies. And then finally, after it recreates the exact environment that we need to run the code in, as I mentioned before, it will go into the configuration section. It will pull the new parameters that we put in, and it will inject them into the code execution during runtime, meaning that we have full control of whatever hyperparameters or data that we push into, or we define this experiment to run with. We have full control of this over the web UI. Now, Mariana, you asked a question about comparing experiments. So this is exactly where I'm going now. So now I'm basically selecting this new experiment that is currently running, and the experiment that I ran very shortly before from the web, from my PyChart. And this is, by the way, the reason that I said that every line here that you see is a Pythonic code execution that has either happened, is happening, or will happen. So the completed one has happened, the running one is happening, and the draft one is in potential to run at some point. Okay, so now after we have both experiments selected, we can actually click on compare and see the differences between these two experiments. So at the start, as I mentioned, I'm running on a Windows machine. As I said, I hope you don't judge me. I have like some strange amount of RAM memory, and a 2080 is my card. And this is the experiment I ran on my local machine, and this is the experiment that is running remotely. And as you can see, the remote experiment is running on an entirely different operational system, on a Linux machine, basically. It has a Tesla T4 GPU, which is much more stronger than 2080, which also explains why the experiment was going much faster. In the hyperparameter section, I can see actually the differences between the different hyperparameters I input. So the original one ran for 10 epochs. The new one is going to run for 13 epochs. Learning rate, momentum, and seed, I changed them all. And now if we go into the scalars, perfect. It looks like the new experiment finished running. And maybe let's change it to something, I don't know, easier to tell apart. There we go. So you can see that the original experiment, the red one, ran only for 10 iterations, and the new one actually ran for 13 iterations. So I'm showing you like very direct evidence that I can control the parameters themselves through the web UI. Of course, the values of all of the different scalars are totally different because I put in totally nonsense values into the hyperparameters. But the idea is that I'm showing you now that one experiment ran for 10 iterations, for 10 epochs, while the other ran for 13. And as I said, we basically have control over all of the parameters that we input. Any questions so far? Yes, Igor.
Hello, thank you. I have one general questions about your platform. So let's think that I'm a customer And I understand that I don't need all of these models. And can I choose it separately? I mean, I understand that I need a development model, and I, for example, don't need a tracking model. So can I choose it separately? And yeah.
Sure. So as part of the model repository itself, so if we go back into the examples, as part of the model repository itself, you can archive or delete models. You can move them into different projects, and you can basically create whatever a logic of what you seem or deem worthy of production by yourself very easily. So you can have, like, for example, production only project. So once a model, you see, okay, it is a very good model, this is exactly what I want, you can simply move it to this project. On top of that, you can add tags, or you can even publish it. So basically, you have a lot of control of how you want to manage the important models, and the other models that you don't care about, you can archive them and then later delete them. So if I go into the archive, I can simply delete them, and also the file will be deleted.
Mm-hmm. Yeah, thank you. And also, I have now one question. And can we install only one of this model? For example, not on. For example, I mean that I need only a part of this platform, not all of these models, like tracking and develop. I need only a developed system.
Yeah, you can do that completely. The system is also very modular. You don't have to all of the different features. You can pick and choose basically what you want to use. So you're not in any way. And we also, as a philosophy of the product, so to speak, we try to be as agnostic as possible. So we don't care what type of model you're using. We don't care what type of cloud you're using, what type of machines. Everything is available, and you can pick and choose exactly what you want to do and how to do it.
Yeah, thank you.
There you go.
Yeah, Nathan, I have another one question. I think you have already highlighted before how the best model is selected, but I think I didn't get it right. Let's say I have some scenario for out deploying of the best model trained. So I have some schedule of training of a model, and I have a scenario of deploying it. So if I have some difficult logic, when I say difficult, I mean I use several metrics and several conditions above to select the best model for deploy. Does this scenario is supported by ClearML?
100% out of the box. As long as, and as I said before, as long as you have your own heuristics or parameters to which decide this is the best model or that is the best model, ClearML supports it out of the box, and we don't care. We just enable you to highlight whatever is the best model, or even automate whatever is the best model, and then delete everything else.
Thank you.
Yeah, okay. I think I will ask a question now. So you mentioned high modularity of the platform, and as far as I understand, you have something in community open source edition and something in like enterprise edition. Maybe now is the time to highlight what's in open source and what people can have in an enterprise edition.
Okay, so I will keep the open source to the enterprise discussion a bit towards the end, or even better, I will simply say what is part of the open source or what is not part of the open source as I present it. So far, everything that I showed you, everything that I talked about is entirely part of the open source.
Yeah, okay. Yeah. Any other question, guys?
Yeah, I have another one question. Coming to ClearML, what kind of metrics for me as administrator of ClearML do you provide from the box? What about supporting this instrument? Can you highlight some tips or hints? Is it easy to run this inside my environment, let's say on some cluster, support it and so on? Maybe some, just some general ideas.
Okay, so I touched on the second point. In regards to what you have or how to manage it, is basically you have full capabilities to monitor everything. Basically, everything that I'm doing here through the web UI, you have a REST API with which you can work to do automations. Now, out of the box, for the admin panel, so to speak, you can see the users, you can see groups, and what access they have per group or per user. On top of that, you also have configuration vaults, so you can actually apply configurations to wider groups of teams. But finally, you don't have any specialized visualization of how much resources this person is using or that person, or how much anyone is doing anything. However, all of this information is already part of the system. So for example, if you want to create some sort of billing capability where you analyze what amount of hours or minutes someone was using training or running on some certain machines, you can actually very, very easily automate all of this because you have a REST API with which you can basically pull all of the related information to each task execution. Each task execution is, by the way, related to a user, and this way you can actually create your own custom dashboards and views according to what you deem relevant. So out of the box, we don't really analyze anything that you're doing because we're also not interested in what you're doing. It is your business. But you can actually create any type of dashboard to visualize what you want to visualize.
Thank you. Thank you.
Any other questions? Hi, Artyom.
Yeah, Dan, first of all, want you to thank for informative and clear presentation. I want to inquire about the integration capabilities of ClearML. Specifically, does it offer out-of-the-box integration with Git, such as GitLab, for example?
Out of the box.
Yeah.
Out of the box, but by default, whenever you run your code, we already detect what repository, what commit ID you're running with. And also when we do the orchestration layer, we will basically use comments to clone the repository. So Git is integrated with ClearML out of the box. You don't have to do anything extra.
Okay, great. Thank you.
Okay, any...
Maybe we should continue for now.
Okay. So next up, we have data management. And for managing data, we have two different features. So the first one that we have is what we call data ops, or just data sets. And this is a fairly straightforward feature for managing both or all types of data. So when I say all types of data, I basically categorize data into two options, either structured or unstructured. So this feature supports all types of data, and you can think of it as basically a catalog to the data that you have. So it's a list of files that you can see. You can version it, meaning that you can add or remove files from a version, and whenever you pull a specific version, you will be pulling only what you expect to be pulling. There is a way to add some visualization on top of our data. So here I have some spectrograms with some sound files. Then I can have some histograms with some tables as well. And the idea is that you can very simply pull the data with a single line of code, like dataset.get and .get local copy. And the ClearML SDK will fetch everything and download everything for you. Now, one important thing to mention is that from ClearML platform perspective, We never handle data. We never touch your data. From the ClearML perspective, this catalog of data is sitting on your storage, and we simply have a link to the data itself. So whenever you're working with the data, basically, you will be querying the backend. What is the link to this version? The backend will return you with the link, and the SDK will automatically download and fetch everything for you, so you don't have to worry about getting the data itself. There is caching behind it, so if you've downloaded certain chunks of data before, you don't have to worry about that. The cached chunks will be used automatically, but the idea is to be as straightforward and as simple as possible, so we have a good basis for managing data without too many restrictions. Any questions on this one?
Can you please show example with data sets, not audio, but tables?
So tables, it would be basically the same. For example, we have a preview of some table here, and as the content, you would simply, instead of having like folder one, whatever the name file .wav, it would be like whatever file name .csv.
Is any information about titles, for example, or maybe like something interesting of datasets?
There isn't something very interesting to see or show in this section, because basically you're just having a way to version your data and access it very simply through the code. The data tool itself, you also register it either through CLI or through code itself, but the idea is to make it as easy to use and as general as possible. But of course, the features supports tables, not just sound files. It supports any type of data. We are entirely agnostic to the data.
I mean, any meta information about tables.
Any what about tables?
Any meta information?
Metadata.
Metadata.
Yeah.
So yeah, this is the problem. All of the metadata would be logged also as another file in the catalog. So you can expose parts of the metadata through the preview section, but this is something that you need to do explicitly through the code. But in the end of the day, it's not designed to present you the metadata. Now, Mariana, are you talking about unstructured data or structured data?
Structured.
Structured, okay. So for structured data, we don't have any special way to present the metadata. Basically, we can see the contents of a version, and we can add the menu. We can manually add previews to the version as well.
Thank you.
Mariana,
Sure.
and to clear your question, do you mean by metadata, do you mean like descriptions of features or something like that?
Yes.
Yeah, okay. So we have another question from Konstantin in the chat. Are you copying the data locally, or are you caching it?
Okay, so from the perspective of the data itself, whenever it is in storage, it will be stored wherever you store it. So S3, Google Cloud, NTFS or NFS, like locally on your machine. Whenever you are doing the training, and the training will be done on the client side, on the machine that is doing the training, the SDK will run there, and it will try to download the data according to the link that it is getting. Now, if parts of the data were downloaded before, which is basically caching chunks of the data, this is fully supported out of the box. If you've downloaded some chunks before, you don't need to re-download them again. The ClearML SDK handles all of this for you. I hope it answers the question, Konstantin.
Yeah, I think.
Sorry.
Yeah, Mariana, sorry. I think I will elaborate the question of, or continue the line of question of Konstantin. So, and if I have like my data in data lake or data warehouse, in tables, in some data engine, in SQL or something like that, do you have any kind of connectors or drivers to extract the data, or should I make my own extraction pipelines?
So yes, but yes to the second question. It is supported by the system, but you will have to make your own connections to the data between the datasets feature to the whatever database that you are using. It is very simple, or much more simple than other solutions, because all of our code is open source, so it is very, very easy to build on top of it. So you can make these connections very simply by just looking at the code itself and saying, okay, here I have to exchange this and this and this, and basically do this connection together. So to give a short answer to the long answer, out of the box, there isn't anything that is supported, but you can basically create your own code for that and visualize it for ClearML.
Yeah, okay, thank you. And sorry, we interrupted another question from Mariana.
Maybe it will be not correct question, but I have read about DVC, data version control instrument, and what is advantages between ClearML and DVC?
So this is a very good question. This feature is very, very, very similar to DVC and to the way that DVC works. The main benefits of this feature over DVC is that the amount of code integration is much, much smaller. In DVC, you need quite a bit of code to integrate with the data directly. In ClearML, basically, you can expose the data that you are running with simply through a hyperparameter on the experiment level. So actually, you can go into the configuration. If you add in the configuration itself, like a dataset name or dataset ID, you can expose it very easily. And unlike DVC, we don't require much code integration. It's just one line of code to pull a specific version, and it also integrates with the parameters that we expose.
Thank you.
Okay, any other questions for this part of the demo? I think no, so I think we can continue.
Okay. So next up, we have the more advanced feature for managing data. And this is specifically for unstructured data. And this feature we call the hyper datasets. And the idea with hyper datasets, this feature is built specifically for unstructured data. So images, videos, PDF files, text files, sound, audio, whatever you like. This is the feature that is for this. Now, what we do with the hyper datasets is that we take all of the metadata. So when we talk about unstructured data, let's go into the most basic example, for example, computer vision. So in computer vision, we have an image file, and we have the accompanying metadata file with all of the annotations and all of the other metadata related to it. So we use all of the metadata. We manage the data itself using links, or basically pointers to the data. And we built an abstract layer that enables you a few capabilities. First one is that now you can actually version both the data and the metadata, meaning that you can change some add or move data, or add or move or modify metadata, and you can lock the version once you are happy with it. And by locking the version, this means that the version can no longer be changed at any point. But of course, if we want to continue working on the data, we can simply create a new child version that will inherit everything from the parent version. So first of all, we have the versioning. Second of all, as you can see, we have actually visualization of the data. So we can see the images themselves, including the annotations. Of course, this is not limited only to images. We can basically work with any type of data. The only limitation for visualization, and I didn't mean to rhyme, is whatever your browser is capable of previewing or showing. So JPEGs, MP4, the browser can show. What can the browser show? AVI files, I think it doesn't show. So for example, you would need to use something else. But from the system perspective, you can use any data. So next up, we have, this is the visualization, which is very nice. But then comes the big change. So in the previous feature that I showed you, the regular data sets, you can basically choose to pull a specific version and train on that, or specific versions and train on that. When we are working with the hyper data sets, now we are working with slices of data, so to speak. So we can say, okay, from this version, give me all the images with apple, or give me all the images with both apple and banana. And you can see that out of 5,000 images, I have like only 24 images with both apple and banana. And the idea is that now your work with the data becomes much more data-centric. So now you create queries per experiment. Now I will go back to the experiment itself, and actually, let me find a nice looking example. Okay. So the section that I skipped earlier was the data views. And the data views is the connection between the hyper data sets and the experiment object. And now we talked about code integration. I said that integrating with ClearML is just 2 lines of code. In the case of hyper data sets, it requires a bit more code integration. We're talking about 5 to 10 lines of code, nothing major. And the idea is that first we select the input that we want into the experiment. So we select some data sets and then some versions inside those data sets. This is the first part. And the second part is that we actually create filtering on top of those versions. So for example, here I have from Coco, from Terrain 2017, give me all the images with Apple. And let's say from Cityscapes, let's add, I don't have any annotations there. Let's see if I have something here. No, I don't. Okay, let's go back to Kitty and just use a different version. So for example, now I can say, okay, from Terrain 2017, give me all the apples. From Terrain 2014, give me all the bananas. The system is also capable of oversampling. So you can say, okay, for every apple that I get from Terrain 2017, I want to get two images that have the annotation label of banana. Now, this querying capability is not only limited to the annotations themselves, but basically any type of metadata that is connected to the system. So you can say, okay, give me all the images from this version that were taken last year in Paris during autumn, for example. So you have full control over exactly what query you give back into the backend. And finally, very importantly, is that you have full control over the iterator that is feeding you the data. So you can either do sequential order, so this will basically fetch you back frames or images. We call them frames, according to the order that they were registered, or even if you're doing random, you have full control over the random seed. So you can always reproduce your experiments one-to-one, and the idea is to be able to reproduce the experiment on the level that you will feed the same exact frame in the same exact order that you did this before. So if you have a data view with some iterator predefined, you will be able to always reproduce the same exact order. Another part of the hyper data sets feature is that the system also supports multiple data views. So you can have a data view for training, and you can also have a data view for validation, and each one of them can have a different query. I think I covered pretty much most of the feature. Any questions so far?
Yeah, I think I have a question about annotations and labels. Maybe I didn't get it. So where this labels and annotations come from? Is this some kind of generic model, or well, maybe I will give example. So it's okay with apples and bananas and cats and dogs and so on, but for example, if we have like some computer vision problem in industry, I don't know, maybe the example is we have a production line of assembling some engine, and in some step of this production line we have a palette or tray where we have some parts of the engine. So we need like very specific annotation. So this part is like some, I don't even know how to say it in English, some part of the engine. And so how will I get these labels in the system? Do I need to train my model and to do like this labeling procedure manually somewhere else? Or do you have some functionality for manual labeling and the process of labeling?
So that's a good question. Basically, the way that we expect the system to work, or we expect the users to use the system, is that we don't define ourselves as an annotation tool or auto annotation tool. However, you can do auto annotation through ClearML, but basically the assumption is that you have already the data and you have the metadata, and then you just register it into the system. So for example, you use like a third-party annotation tool and you have a team of annotators. Once in a while, the annotation tool, you can export all of the data and plus annotations that are available in that annotation tool. Then you would take it and register it into ClearML, and this way you would have everything showing up in the web UI. So it's not auto detection.
Yeah, okay.
As I mentioned, from the system perspective, we only have metadata, which you can think of as basically like a JSON with some metadata accompanying, and a link to the raw data itself. So we don't do any transformations on the data itself. It's all up to you. We basically enable you to do it. Now, one thing I do want to touch on is actually annotations in the system. So the system itself, it does enable you to do annotations. So I can actually move the annotations around. But one point that we do mention is that we don't advertise our tool as an annotation tool. This is more of a QA tool, meaning that me as a data scientist, I'm going through the data and I see something misaligned. So instead of having to go into the code, fetching the frame, changing the annotations through the code, I can simply go and align the annotation themselves, or maybe create new ones if I want. But as I said, we don't advertise it as an annotation tool. This is more of a QA tool.
Yeah, okay, thank you. So guys, any other questions? You good?
Yes.
Yeah, I would like to return back a bit. When we were discussing models as an artifacts, you said that there is an option to publish it. What do you mean? My question is, let's say data scientist working inside this system, and he produce ML model as a result of his work, and I, as a MLOps engineer, would like to create a service from this model. Do I have such functionality inside ClearML or something else?
Short answer is yes. Longer answer is it depends on the use case, how you want to implement it. But we basically bring you all of the required features to do exactly that. The next thing that I'm gonna touch on our pipelines, and this, I think, will give extra information to your question. Does that make sense? Great.
Yeah, okay. I will wait for an answer.
Any other questions?
I think for now, no, so we can continue.
Okay.
Can I ask a small conceptual question? Do I understand correctly that this workflow is equally applicable to any type of model, let it be computer vision model or large text model? Do we have any limitations here
So
in terms of model size, data type, or anything else? Can I, for example, push video files as input to a data set for labeling large text?
yeah, you can push whatever you like. The system is completely agnostic to what type of model or what type of data that you have. Just from the perspective of visualization in the web UI, in the end of the day, I'm using like a browser, yes? So the browser has its own limitations on what it can visualize. For example, I don't know, Parquet files or like complex 3D models that are taken in as data, for example, I don't know, for medical imaging, you can use it as data, but your browser can't visualize it. You understand what I mean?
Yeah, okay, thanks.
Any more questions? I'll take it as a silent no, and I'll continue. Okay, so next up we have the pipelines. And the pipelines are basically a capability to connect together different tasks and orchestrate them on different types of machines. So what you're looking at here, this is a pipeline or an execution of a pipeline. And every node that you see here is actually an experiment by itself. So if I click on any one of the nodes, I can go into the full details, and this will take me to the experiment itself, where I can see all of the console outputs, the scalars if relevant, and so forth. Now, because every node is an experiment by itself, this means that every node can be executed on entirely different machines. So for example, create data set, pre-process data set, verify data set, all of these don't require a GPU, so you can run them on CPU machines. Train model and, train model 1, those can be run on GPU machines, and you have full control over this. Now, the way that pipelines are built is using code, Python basically, for using our SDK. But the main power of the pipelines feature is that it is not a regular DAG diagram that you would create yourself. The logic here is actually driven by the code itself, meaning that you can actually create if statements. So throughout a pipeline, for example, if some parameter is under a certain score, then go into this branch of the pipeline. If it's over this score, then go into that branch of the pipeline. You can also do for loops. So instead of writing the same step again and again, you can just do for loop, recreate like 5 times or 10 times, however many times you want, the same step, and just run it. And all of them will run in parallel. And the idea is that you have full control over either sequential running or parallel running, and also obviously controlling which types of machines each step will go into. One extra feature that is really nice is that we also support caching steps in pipelines. So the purple ones that you see, this means that they are cached. Now, by cache, what does it mean? Caching means that if the code doesn't change and the input doesn't change, don't run the step. Just use the previous step's output and use it as this step's output. So for example, here, I have this pipeline execution and I have the previous pipeline execution. So in this case, instead of running the create data set and the other 2 steps, it basically goes to the previous pipeline. It takes the output of create data set and uses it as the output of this step. Of course, the caching is fully controllable, so you can choose if to cache steps or not to cache steps, it's entirely up to you. Questions? Yes, Igor.
Yeah.
Good.
Nathan, you said that this is not only a simple scheduler like Airflow or whatever, but do you have functionality to schedule such pipelines?
Yes.
Okay.
There is an application that is dedicated to scheduling, so you can schedule pipelines. One extra thing that I didn't mention, of course, you can run pipelines from the web UI, including exposing whatever parameters that you want. And another thing is that because everything here is available through a REST API, you can actually trigger pipeline runs externally. So, for example, if you push code into Bitbucket or GitLab, okay, you can configure it to run an entire pipeline inside ClearML, basically covering all of your CI/CD needs. And if I go back to the experiment level, when I was talking about the execution, I mentioned that you can actually edit. Wait, let's go to a project that is not that large. Here you can actually edit also the execution. So you can run on any type of, not any type, but any checkpoint, so to speak, in your code. So you can run on a specific repository, and you can run according to a tag or the latest commit in a branch or just a specific commit. But the idea is that you can automate all of this and also schedule all of this as well. Yes, Mariana.
Can you please show back pipeline? Yeah. On the first step, we create data set, and after that, we process it. How it's with the data set that have built in the first step, he will go to the another step. Yes. And what the kind of data can I send from the step to step?
I'll answer the second question. Any type of data that you want, either like regular files or even pickles, if you like. And the idea of how everything gets transferred around is through the artifacts. So as I mentioned before, the artifact, it can either be the output model of experiment, but it can also be any type of data that you want to move around.
And only artifacts, or maybe some parameters? Yeah, also a parameter also, okay.
Of course, this is part of the SDK itself, that you can actually pass parameters in between pipeline steps as well.
Thank you.
Artifacts and parameters.
Thank you.
Sure. Any other questions? Okay. Then going forward, let me find the right server. There we go. So next up, we have reports. Reports are very similar to overviews, as we saw previously, that are connected per project. But the idea is that reports are disconnected from a specific project, so you can just create reports and report on anything that you like. Again, this is a Markdown editor where you can embed outputs from the system into the report. And the important thing is that you can either share the report through a link to your colleagues or just export it to PDF and then share it through email, for example. So this is the reports. Another set of features that we have, and let's go back to the original server. So we have a few dashboards for the machines that we have connected in the system. Another very cool capability that we have on the side of orchestration is actually the autoscalers. So the autoscalers will work somewhat similar to a regular agent. meaning that they will listen to a queue, but instead of just listening to a queue and doing work by themselves, they will actually spin up and down. In this case, this is an AWS autoscaler, so they will spin up and down EC2 instances, handle whatever workload that you have, and then spin them down. Meaning that you no longer have to manually provision machines. Everything is done automatically. The machines are spun up and spun down for you. Another few features that I do want to cover, just taking into account the amount of time that we have. We also have what we call applications, and applications are basically wrappers around more advanced capabilities. So for example, we have an application for hyperparameter optimization. We have a task for scheduling, a task for triggers, but I'll just cover the hyper optimization one because it is, in my opinion, the coolest. So what this, Pavel, just give me one moment. What this application will do, it will actually take a base experiment in the system. So we identified using the experiment ID. Then we select what optimization method we want to use. So the options are Optuna, Hyperband Bayesian, Random, and Grid. Then we select what metrics we want to optimize according to. And finally, what parameters we want to play with. So for example, in this example, we have descent, argument/descent. So we say from 0 to 100, go in steps of 5. So 0, 5, 10, 15, and so forth. And what the application will do, it will take the original experiment, it will clone it as many times as needed, inject new parameters into the experiment, and push it into execution. And the end result will be simply a dashboard of the best performing experiments that you had, some parallel coordinates, and of course, a table of the most best performing experiments that happened. Okay, so this is a good cover of HPO. Pavel, I'm sorry for delaying you.
Yeah, about the time. So if you have another half an hour or so, we're not restricted with the time, so we can continue with a nice pace. Yeah. So
yeah, I have another 50 minutes, so it's not a problem on my side.
okay. Okay, great. So I think I don't know. I actually have a question about reports. We just skipped it really quickly. So do I understand correctly that, for example, as a data scientist, I can write any metric, any visualization on Python that I like, and to embed it into reports?
Yes,
Or
exactly.
do you
So
have it?
just to give you an idea of
Okay.
how it works. So I go into, let's see. I go into some, let's see if I have scalars. Okay, I have plots, that's good enough. So I have some experiment, I have some outputs in the system. I can, every output like scalar, plot, debug sample has this copy embed code button. And what this enables you is either to embed this graph or plot inside a ClearML report, or even externally, for example, like Tina mentioned at the start of the call, into Monday or Jira as well. And if I click on embed in ClearML report, so this is the image that I chose, I can go into my report. Let's say don't care too much about the order, so I can just edit here. And I will have this plot showing up in the report as well. And basically, you can embed anything in the system into these reports.
Yeah. Okay. Thank you. Okay, guys. Any other questions? You good?
Yeah, sorry for one more question, but I would like to know something about ClearML serving service. Can you cover a bit?
Sure. Okay, so serving by itself is another module of ClearML. At the moment, it is not directly integrated with the web UI, meaning that you can't, like very similar to how I took an experiment, changed some parameters and pushed it into execution. At the moment, you can't like right-click a model and start serving it as an endpoint. At the moment, it is done through a CLI. Basically, you have a CLI that connects to our model repository. Let me find where the relevant commands are. There we go. So basically, you have a CLI that connects to our model repository. You can start a serving session through a CLI and then add endpoints to be reported or to be connected to a specific model in the system. And in the end of the day, this basically gives you a REST API endpoint to talk to, so you can communicate with it. What we do in the background is basically we aggregate all of the relevant data to the serving session itself into Kafka. Then we ingest it into Prometheus, and in the end of the day, you can visualize everything through Grafana. You can add the alerts or triggers through Grafana itself. Again, and by the way, the full solution is on top of Kubernetes, meaning that your models can actually scale. So if you start getting more and more pings into a specific endpoint, the autoscaler will automatically spin up another node for serving this specific model. And now getting back to the integration with the ClearML web UI. So at the moment, you would be visualizing everything through Grafana. In the next 2 versions of ClearML, and when I say 2 versions, this means not the one that is being developed right now, but the one after that. I would say about 3 to 4 months, maybe even 2, but I don't want to commit. You will have a full integration through the web UI as well, so you will be able to right-click a model in the web UI, set all of the different parameters for serving it, and start serving the model, including all of the visualization and reports inside the ClearML web UI.
Thank you, Nate.
Yeah, Kostya.
Yeah, it's slightly different question. It's not technical. I was wondering just what does your client base look like, and how mature your client's supposed to be in order to use this type of tool? Size of the team, for instance, can be an indicator.
So basically, to start using the platform, there is no criteria, so to speak, because we are open source. You can start using it from any point at any size of team. Usually, when we talk about the more advanced licenses, which are the paid licenses of ClearML, like Scale and Enterprise, we're usually talking about starting with a team of 5 or 10. Then this is when you start getting the benefit of more advanced capabilities of ClearML, like role-based access controls, SSO, LDAP integrations, and things that are more on the enterprise side for managing larger groups. If you are a smaller group, you can use the open source. And just to give a comment on the customers that we work with everyone from very small groups of 5 people all the way to very, very large groups of 100, 200 users in very large organizations, of course.
Who is your audience to sell when you do a large organization? Is it data science, a chief data science type of thing, or someone above, on the business unit side?
So
Can I take this?
yes, please, Tina.
So from a bird's eye view, we have over 1,600 organizations using ClearML that ranges from startups to educational institutions to large companies, and over 250,000 users on ClearML. And that's mostly because we are open source and we have a number of installations throughout a lot of institutions. With regards to size, as Nathan mentioned, if you're using the open source, it's up to you how many users you want to support. yourself. When you come to us, then we can support starting from 5 to 10 users, 5 to 10 seats. And we also have a free version. So if you go to our website right now and you just want to sign up for an account to play with it where you're on our community server, you can do that. We support a free version of our account from 1 up to 3 people. So a lot of students actually take advantage of this when they're just doing reports or people who are just testing out the system for themselves.
Okay, thank you very much. Yep, that answers my question. Thank you very much.
So back to you, Nathan.
Sure. Thank you for helping on that one, Tina.
Yeah, okay. Any other questions? You good?
Yeah, Nathan, coming back to serving service, you said that, let's say in 4 months, it will be available through user interface. You mean in open source version or enterprise?
I'll be honest, I don't know.
Tina, maybe you know?
Let me get back to you with that because I also don't know the answer to that yet.
Okay.
But if you want to send me an email with your question, my email is tina@clear.ml, and because I don't have your email, so you can send that to me and I'll let you know.
Okay, thank you.
Okay. So maybe I want to clear out some couple of further questions. So as Tina showed on the first slide, like good, nice, great picture of ML platform, and we walk through the components of the platform in the ClearML. And to clarify, so the IDE or the development training environment is should be my own, like Jupyter notebook or I don't know, PyCharm, yeah, installed independently on ClearML, or do you have like built-in environment for developing the models for writing the code? I think I think something in the applications tab, like Jupyter server or something like that.
Yeah, so one of the things that we enable users are remote sessions, and this we utilize using the ClearML agents, the orchestration layer. Basically, we handle all of the SSH tunneling and the heavy lifting for you. And the end result is what you get is Jupyter Notebook or VS Code on your local browser, but all of the computation is happening on the remote machine. I think I launched a job just a bit before we started. Yeah, it died because we went over the time limit. But basically, the idea is that you have 2 ways to get this remote session. The first one is through a CLI tool, basically writing ClearML dash session, and you will get this Jupyter Notebook or VS Code on your machine locally. In the enterprise versions, what we have as part of the applications is that we can actually start up this service through the web UI. So the one that I launched just now, this VS Code session is actually connected to an AWS autoscaler. So this is why it's taking time. So what is happening in the background? I launched this job. So this job is connected to AWS autoscaler. So an EC2 instance is being spun up. Once the EC2 instance is finished initializing, this application will take care of having the ClearML session inside. And then basically what will happen if I click on this, the previous runs, I will get a link here in the OpenIDE section that I can click. And this will give me this, in this case, VS Code environment in my browser. But again, all of the computation will be happening on the remote machine.
Yeah, okay. Thank you. Any other questions, Mariana?
When you on the start of the demo, you on the presentation you said about Kubernetes that you don't use Kubernetes on to deploy models. Yeah.
Just important. We in general we don't require Kubernetes. We can run on type of any infrastructure. In the specific case of our serving module, by the way, you don't need Kubernetes. You can run it as Docker Compose. If you want auto scaling for your models when you are serving them, for example, let's say you have a model and it is getting, I don't know, 10 requests per minute. Okay, so you put this node up, but all of a sudden something happens and you don't get 10 requests per minute, you get 10,000 requests per minute. And the node cannot handle this amount of requests. So you need some capability to auto scale, maybe bring up another node that will be able to redirect between the different API requests between the two nodes, and then handle both of them in real time. So in this case, you do need Kubernetes to auto scale the serving solution. Does that make sense?
Thank you. And one more question. This serving is about online models. It's better for online models, but sometimes we need to product batch models that go by scheduled and massive data sets. Do you have how do you deploy this kind of models?
Fully supported, also part of the serving solution. All of this supported, both online inference and batch inference. All of this support as part of the, not even the main solution, just the solution itself. Even if you just spin up a bunch of Docker composers, it will also work. So fully supported.
And what instrument will schedule it? It's not in the platform, or
the scheduling itself is part of the platform itself.
Okay, thank you.
Yeah, okay, one more question from me. So since we discussed how you compare and position yourself with a tool like DVC, I think you're getting asked a lot about how you compare with MLflow regarding like experiment tracking and so on. So maybe you can comment something on it.
No, I think you will excuse my brazenness or audacity, but I will say we are much better than MLflow on every single level. Part of the MLflow was very, very good like 5 years ago. But today, I'm sorry, it is an old technology and it does not compare to the actual needs of the industry. Okay, so we have all whatever MLflow offers, much more and much more easily and much more friendly to the user, so to speak.
Yeah, okay.
I'm sorry if it's a bit concise without too much information, but
no, I agree with you that MLflow was like I don't know, state-of-the-art technology for experiment tracking 5 or 6 years ago, but now it's like the ML platform is much more than just experiment tracking. People, the data science team need much more functionality from ML platform. Yeah, so if you have time, maybe one more question.
Sure.
Yeah, okay. Igor?
Yeah, I always have questions. Nathan, I have such question. For instance, let's say we have other tools, Airflow, MLflow, doesn't matter. Do you support any migration from other servers?
So out of the box, no, but it can be very, very easily converted. So you can import data into ClearML very, very easily. You have a full REST API, which is very, very easy to manipulate with basic knowledge of code. I'm not a programmer. I can do it. If I can do it, anyone else can do it.
I hope.
Really, I'm very, very bad. I don't even want to show you my code.
Okay.
Yeah, but basically importing is very straightforward and easy. You can usually create driver scripts that will transform whatever you logged in one system or one framework into ClearML very, very easily.
But the short answer is yes, and we do have customers who do actually use MLflow and use Airflow in conjunction with ClearML. So it's possible.
Yeah. Okay. And one more question from me. So I want to clarify, what is the definition of the project? Is this like the project is a model and its experiments, or the project is like several models, several experiments, pipelines? Yeah, okay.
So a project is basically a set of experiments, models, and also pipelines. Basically, you can think of it as directories. You're basically managing directories. Inside those directories, the main objects you can populate them with our experiments, models, and data views as well. But basically, you can create whatever structure that you want. You're not really limited to say, oh, I have to work like this or like that. You're basically free to work in which way you like, usually according to your use case. When we work together, then we advise according to what we understand from your use case. We say, okay, the best plan forward for your use case will be this way or that way.
Yeah, okay. And so I think it doesn't have to be like a ML model project. It actually can be like any analytical pipeline project. Yeah, okay, great.
But if you notice, many times throughout the demo, I said that every line here is a Pythonic code execution. And this is for a good reason, because it doesn't only, the task object itself, it doesn't only relate to experiments. It basically relates to any Pythonic code execution. So you can run any Python script, you can add the ClearML task init into it, and then you will have all of the results of this code execution. So, of course, this also relates to the pipelines. For example, even when we were looking at the pipelines, like verify integrity or create data set, per se, this is not an experiment. This is a Python code that is running to register a data set. But, of course, even if it's not an experiment, all of the related information to its code execution is still logged into ClearML.
Okay. Thank you.
And I think, oh, Marianne has a question, but before we wrap up, Nathan, before you go into the difference between open source and enterprise, maybe you can also talk about the new open source fractional GPU capabilities available to open source that we just released.
Yeah, very good that you mentioned this, Tina.
Sorry, don't want to cut off Mariana's question.
It's about my presentation. I have a question about pipelines. You have pipelines, and for example, I have tuned my pipeline, and can I serve it as a model later? Yes.
Yes.
Thank you.
Okay, so I will just touch briefly on multifunctional GPUs. So in the open source, we already released the option to use, to separate basically GPUs according to how you want. And in the demo, what I showed you, I ran an experiment remotely in an entirely different machine. As I mentioned before, this is a Linux machine. One thing I didn't mention explicitly is that I did mention it, but very shortly, not exactly explicitly, is that this experiment ran inside a specific Docker container. So when we run experiments, we have control if we want to run them on the bare metal machine itself, or if we want to run them inside Docker containers. one of our latest releases are basically contain Docker images that are already on the driver level predefined to consume only a limited amount of GPU memory. So like 2 gigabytes, 4 gigabytes, 8 gigabytes, and so forth. So now you can actually, excuse me, you can actually limit whatever amount of memory you want the experiment to have accessible through the container image that you are defining. So here I use some image from NVIDIA, but of course you can simply use the predefined images with the restrictions on a GPU memory usage. And this, of course, is not, you don't have to configure it on the experiment level. You can actually configure it on the agent level, meaning that every experiment you push into a specific queue, by default, will be limited to a specific amount of GPU memory, meaning that you can actually fractionalize your GPUs very, very easily and straightforward. Tina, I hope this pretty much covered the main points.
Yeah, and also one of the cool things is we can do this for basically all of your NVIDIA GPUs. You don't need an A100 to do this.
Exactly. So this fractionalizing is not limited to any type of GPU, not A100 or whatever. You can fractionalize any type of GPU. So for example, even on my personal machine, I can take my, wait, there we go.
Your 2080?
My good old 2080, and with the 8 gigabytes of memory, I can split it into two queues, one with 4 and another one with 4, or even more, 2, 2, 4, or 2, 2, 2, 2, with gigabytes of memory, however I would like. But the idea of fractional GPUs is that you can very, very easily now actually spread apart resources that you have.
Perfect. Thank you, Nathan.
Thank you, Tina.
So guys, are we going to wrap up for today?
Nathan, do you want to just overview of open source versus enterprise capabilities, just so everyone knows?
Yeah, very good idea. So just to give you an explanation of the different capabilities that are available for you through the open source and through the enterprise version. So I'll go back to the web UI. So all of the experiment management, all of the orchestration is fully available in the open source, or 99% of it. Data sets, the regular data sets are available in the open source. Hyper data sets are available only in the scale and enterprise licenses. Pipelines, entirely available in the open source. Reports, entirely available in the open source. Orchestration, this dashboard is not available in the open source. Autoscalers are available in the open source only as code examples and not like direct UI applications that you can play with. Workers, queue sections, so the entire orchestration layer completely available for you. Applications, so applications are available only in the scale and enterprise or even the Pro, but a lot of them have code examples that are available also in the open source. So even the hyperparameter optimization, for example, you have a Pythonic code example that you can run to orchestrate the HPO yourself. The only difference is that you won't have like a very nice dashboard to configure everything. You will simply need to do it through a CLI where you run some long bit of code and, well, not the long bit of code, but a long bit of parameters after the Python and the file name. Another extra thing to mention is that role-based access controls, SSO integration, LDAP integration, all of these are also available only in the scale and enterprise licenses. But besides that, most of them really powerful capabilities you can already start using out of the box with the open source.
Okay, great. So I think we should wrap up for now. Yeah. Okay. Nathan, Tina, thanks again for coming. It was really productive session and nice discussion. If we have a Telegram chat in our community, so if we have any follow-up questions, we will forward it to you. And I hope you will come again to our event sometime in the future. Thanks again. Thanks everyone for coming, and have a nice day. Have a nice evening. Bye-bye.
Thank you.
Thank you.
Thank you.
Спасибо всем. До свидания.
Thank
Thank you.
До свидания.